Welcome back to Code Snippets. I've been talking a lot about array lists, but I never really mentioned what they were, aside from just saying that they're a fancy array. So, how do we make an array list, and what is it? So, when we just say, here we have an array of strings, and we called it S. So to fill it, we would say something along the lines of S at I equals some string. So I'm going to put the word text. So it's going to take this word text and it's going to assign it to every single spot that we have in our array, which is fine. We're not necessarily wanting to do anything fancy with this right now. And when we wanted to change a value, we could just say S at 4 equals new text or something like that. And if we want to store a new string, if we wanted to take some value that we have in our array, we could say S at 6, right? Or string, well, I don't want to call it string. I'm going to call it A. String A equals S at 6, which of course is just text, but that's fine. And then if we want to remove a value, here we could say something like S at 2 equals null. If we could set it to null, that's sort of like removing it, because again, null is the absence of data. If there's nothing there, that means it's been removed, as you could say. So if we go through, we can print out all the values. I'm going to use a for each loop. So we're going to say sysout string, just like that, because that's the name it gave me. So if we run this, here we get text, because we set everything to text. Here we put null, or we got null because we set it equal to null. We removed the value. Here we got text, and then here's where we modified it to say new text, and then more text, and everything like that. And lastly, if we say something like S at 10 equals something like that. Now if we run this, we get an error that says exception in thread main, blah, 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 index out of bounds exception. So that means we tried to put a value where the array didn't have an index for it. And if we click right here, it'll actually highlight the exact line that it happened on. So we have this string, and we're doing 4 separate things with it. We're either adding, removing, getting, or setting. So most of these are pretty straightforward. When we say we're adding a value, that's here. When we first created the array, such as, we have the IKEA dresser in our house, but there's nothing in it yet, we need to add the values or add stuff into the dresser. We can remove values. Here we said something equals null, that would be removing. We can get values, where we could say, all right, take the value that's at index 6, we're going to retrieve it and put it in string A, so that's getting. And then setting is when we're actually taking a value here, so S at index 4, and we're setting it as a new value. When we have an array list, we need to be very specific with what function we're performing. Here, every single time we did something, all we had to say was S at some index. S at index 4, S at index 6, or 2. Here was S at index I, right? So I'll remove that one because that one just gave us an error. When we have an array list, all of this becomes a different or more specific line. So I'm going to create an array list. Now, how do we do that? So you say array list, then we need these diamond brackets. And inside the diamond bracket is where you're going to specify what this array list is going to store. In this case, we're storing strings. So we want an array list of strings, and we're going to call it array list because I'm not creative. Then we still need to say equals new, and then retype what the data type is, put string in there, and then we need parentheses at the end. Then we're going to do Control-Shift-OFS, and now we've imported the array list. Okay, now this is the same exact thing as saying this. The only difference is the array list is more dynamic when it comes to how much data it stores. So when we create an array, I'm going to recreate this visual here. We created a table of values, and we said 0, 1, 2, 3, all the way to 9. We said there's 9 values, you can't change that, that's the end of the road. With an array list, there's a lot more to it than that. We can do a lot more with it. Oops. There we go. We don't just have to abide by there's only this many values and you can't change it unless you create an entirely new array. So that's why we don't really need to specify a size anywhere when we create our array list. So here, this was adding. So how do we add something in an array list? Well, we would say for int I equals 0, where I is less than, and then here we would need to specify some number. So in this case, we had 10. So what I'm actually going to do is I'm going to declare a variable called length, and we're going to set it equal to 10, just like that. So where I is less than just length, because that's going to represent this variable here. That way we can just avoid some hard coding. We're going to say ArrayList, and then instead of using brackets, we're going to say dot add. And we're going to add the word text. So if you notice, we don't need to specify an index either. We can just add the word text and it gets put into our array list. And if we were to represent that, going back to our table, so let's say here's our array list. It still has an index, it still has a value. It's set up the same way that an array is set up. But when we create an empty array, it had all of the indices in there already, and then we just had to add the values accordingly. With an array list, there's really no indices set up prior. It's sort of just blank like this. So when we say add a value, right, ArrayList.add, if we're adding the word text, then index 0 shows up, and then the word text is added. Just like that. Then we go through again, and we add the word text again. So now it's 1 is text. And then it happens again. Now 2 is text. So on and so forth. So it goes one at a time. So you don't have to worry about, oh, how many values am I going to have? Or, am I going to be over? Will I have no values left over? You don't have to worry about that because it's however many values you add, that's how many values will be in your array list. So if you add in 10 values, like we're doing here, because length is 10 for int I equals 0, rise less than 10, or length, which is 10, we're adding 10 values, then this array will have 10 indices. If we only add 5, then it'll have 5 indices. So it's a lot more streamlined, per se. It's more catered towards the user and not towards how the program is running and how Java works with memory. It's a lot easier to manipulate. But again, you have to be more specific. Here we have to say that we're adding a value. We can't just say that s some value or some index equals text. We have to say ArrayList.add text, because that's what we're doing. Then here, this is where we were setting. So to set with an array list, we would say ArrayList dot, you guessed it, set. And then here it says we need to specify the index and we need to specify the element. Well, the index here 4, that just goes there. Then the element, this is the actual value we're setting. So this new text string is our element, like that. So these two lines are exactly the same thing. Pretty straightforward. Here, we're getting. Same thing as before. When we want to get something, we just say ArrayList.get. So we would say get the index, which is 6, and then we could say like string b equals, like that. And then here, lastly, this is removing. So s at index 2 equals null. This is removing. So the way we remove is ArrayList.remove, and then we pass in the index, which is 2. Except the only difference here is instead of just replacing it with a null value, if we throw in another value right here, like that, when we remove 2 from our array list, it doesn't just set this to null and go on its way. It actually erases the whole thing. I wish my eraser was just a little bit bigger. Okay, we're going to do this instead. It erases that whole value, like this. It pretends it never even existed. Like that. And then it takes the values here and it moves them up, like that. And of course this 3 now becomes a 2, and everything gets shifted around like that. So if there are more values below here, if there was a 4 through 9 or whatever, those would all get shifted up to 3 through 8. So that's what's happening when we remove from an array list. So again, it's very streamlined. We don't have to worry about those null values left over. And that's very important, because if you have a null value, then your program might break. Because if you say something like, where you take a value and you want to do something with it, like invoke some sort of method that doesn't make sense to you yet, probably, but it will later on. If you're dealing with null values, you'll get a null error exception, and that's not good. We don't want to do that. So, having the ArrayList.move, having that being its own method that just gets rid of null values altogether, is extremely helpful. And then lastly, we just have printing out. The printing out works exactly the same way. If we do a for each loop, and here it already recognizes I want to refer to my array list, then we can say sysout string the exact same way. All right. Then if we print this, I'll do another line in between. Okay, so this is the text that was from our string array, and this is the text from our array list. Now if you notice, the only difference is this array list doesn't have a null value in it, because when we said remove, it just removed it. It didn't set it to null. It just completely skips over it now. So again, we don't have to worry about those null values in there. And another thing, if we didn't use a for each loop, let's say we wanted to use a regular for loop. So for that, so how do we reference the length of our array list? Well, you might be thinking we'll just do ArrayList.length, but that actually doesn't work, and it gives you an error right there. So instead of saying the length, we need to say the size and then use parentheses just like that. And now we can say ArrayList.get I, just like that. So this is if you didn't want to use a for each loop. If you wanted to use a regular for loop, this is how you would do so. And I forgot to print it out. Sysout. Now we can get it just like that. Great. And then we print it, and there it is. There's our array list of values next to our string, or our array of strings. And last but not least, there's a couple more differences, specifically with the add method. We can say, instead of just ArrayList.add text, we can say, let's say we want to put, we want to add hello into a specific spot. We don't want it to go at the end. That's where it would normally add it onto. Let's add it onto the beginning. So we're going to put the index first, followed by the value that we want to add. So now if we run this again, it added the word hello at the beginning, and then it deleted the other text. So we don't just have to add at the end, and if I do another ArrayList.add and just say hello, don't specify an index, I just want to prove that this will throw it on, it'll tack it onto the end, and there it is right there. So we can specify where exactly in the array list we can add it onto. So that can be very, very helpful if you have an array list that you want to keep sorted. If you have, these are in a very specific order and I want to keep them that way, then based on whatever you're adding, you can put it exactly where you want to, and then you don't have to worry about going through and resorting the entire array list, which can take up a lot of processing power depending on how big your array list is and what kind of sort you're using. So it can be very, very helpful to just say, all right, add it into exactly where it's supposed to go, and then you don't have to worry about it at all. Now there's one more difference with the array lists, and that's with the remove method. So here, the only thing I mentioned was that you could say ArrayList.remove and then pass in an index. In this case, the index is 2, so it would remove the third item in the list. But there's also another way that we can remove items. Let's say I wanted to remove this line right here that says new text. So all I would have to do is just say ArrayList.remove, and then I would need to pass in the words new text. Just like that. And now, if I run this again, we can see that new text is gone. So what's happening here is we're passing in this phrase, this string called new text, or the string with the value of new text. So what the array list is doing is it's taking this string and it's going to check each value in the array list, and it's going to look for if any of them are equal to this line right here. So what's happening is it's invoking this method called .equals. And I think I've talked about this before. Let's say we have a string that I'm going to call s, and we're going to set it equal to the word text. Then we're going to say s.equals text. Just like that. And then we're going to print out this result. I may have already used the letter S, so I might need to use something different. Yep, okay. So we're going to rename it to S1, that's fine. There we go. Okay. So we have this string called S1. Oh, because I had an S as our array of strings up here. And string S1 is equal to text system.out.println S1. And I'm going to put some new lines around it just so we know what's happening here. So if we run this, we get the statement true. So S, or S1, is in fact the same word or the same string as text. So we can further show this if I put an S2 and set it to the same thing. Then I can say if S1 is equal to, not S23, S2. If we print that out, they are indeed equal to they have the same value. This would be equivalent to saying something like if we had int x equals 2 and then sysout x is equal to 2, just like that. But because we're dealing with strings, we have to do it slightly differently, and these are both true values. So we can't just use these double equals willy-nilly, especially when we're dealing with something like strings. Now, let's say we have something along these lines. If I say s2 equals new string text, and I say s1 dot equals s2, if we print this out, we get that they are the same value. However, if we do sysout s1 is equal to s2, here we get false. Now why is that? We're essentially performing the same exact operation, right? Well, we're not. The difference between the dot equals and the two equal signs, it's a very important difference, but it's not outlined very well in Java. I really appreciate Python for the fact that it separates these between s1 equals s2, as in they have the same value, and they use the double equal sign for that. However, in Python, their equivalent to the double equal sign is the keyword is. So s1 is s2. And if we look, these are in fact two different strings. So I could say new string text in here. This is sort of the long way of creating a new string. You don't have to do it this way. This is just to demonstrate a point. So this goes back to, let's say you have two identical twins. They may look the same, they may behave the same, sound the same, everything like that, but they are still two different people. So these are two strings that are identical. They both are just the word text, and we can print them out and prove that, but I'm not going to do that. Because here it proves they have the same value. The value of s1 dot equals the value of s2, and this prints out true. However, s1 is not s2. They are two separate strings. The twins are two separate people that just happen to have the same value or same appearance in terms of the twins. So these have the same value, but they're not the same string. So that's the difference between dot equals and the double equal sign. And I'm sure I'll talk about this more on later on in a video. Let me try that again. So that's the difference between the dot equals and the double equals sign. But I'm sure I'll talk more about this later on, especially once I go into classes and objects, because that's really what this relates to. So I'm going to delete all this, and we're going to go back to the dot remove. So it goes through and it checks, okay, is new text, is that equal to hello? No. Is that equal to hello again? No. Is it equal to text? No. And it's going to go through and check every single value and ask if it's equal. In this case, none of them are, because we already removed it. If we print out the list before we remove it, then you'll see it is in there, because we're setting it at index 4, or the 5th position, but then we end up removing it. So I can replace this. I'm just going to remove one of the hellos. So if we run this again, now we went from having two hellos to only having one, because one of them has been removed. And I'm even going to put in the new string around these, just to demonstrate that they are not the same string, but they have the same value. And as you see, the first one still gets removed. There's still only two hellos. Another important thing to remember is that it only removes the first instance of it. So how we had two hellos, it would remove the first hello it finds. So this is actually the second hello in the list. Now there's one more thing with ArrayLists that's very, very helpful, and it's the contains method. So this functions very similarly to the remove method, except it doesn't actually remove anything. So we're going to get rid of this. I'm just going to comment it out. And we're going to print out whether or not our array list contains the word hello. So we're going to run this, and it does. So it printed out the word true. ArrayList does contain the word hello. And this again checks for the dot equals. It runs the dot equals method. And I'll probably be talking about methods in the next video, so if you don't know what a method is yet, you will soon, hopefully. So it checks if the ArrayList has a value, or has a string in here that has a value equal to this. And it does, because we have, in fact, we have two of them, but it only cares about the first one. As soon as it finds it, it stops. So we can also say sysout ArrayList.contains, and then we can put something like new string, again, just to clarify that it's checking the value. So it's invoking dot equals, it's not the double equal sign. If we run this, we get 2 trues. So it's checking new string text, and in fact it does find that in there. And lastly, if we were to check if it contains something that's not in the list, and capitalization is important, so I'm actually just going to do a lowercase hello. Oops. If we run this, we get a false right there, because it didn't find a string that matches this value. There's no lowercase hellos in our array list. As you can see, both of the hellos are uppercase, so it didn't find this one. If you're wondering how maybe to sort them, specifically with the swap, I'm going to pull up the code for sorting. So we're going to take this. Hold on, where's the string one? Oh, here we go. Sorting strings. Okay. So I'm going to cut and paste this code into, not this code, but right here. So actually we're going to sort it before we print it out, like that. And instead of strings.length, it's ArrayList.size -1, of course. So we're actually going to copy and paste this to make it easier. Right there. And here. I guess we don't need this line because we're already printing it out. And I'm going to copy ArrayList, and we're going to put it there, and there, there. Replace all these strings with ArrayList. And we're still getting errors because we can't just say ArrayList at index j. We need to say ArrayList.getJ, like that. And ArrayList.getMinIndex. And then here, again, we're getting I, because it's on the right-hand side. But here, we're setting I, because we're taking the value here, and we're assigning it to this value. So we need to say ArrayList.set I, and we're setting it, we're replacing it with this value, which of course we need to say .get, just like that. And then lastly, we need to do the same thing here, .set minIndex with temp. Okay. So now, if we run this, theoretically, everything should be sorted. And it is. So we can sort the array list the same exact way we sorted the string array. And last but not least, I mentioned that when we're dealing with for each loops, there might be an error you could get where you're modifying an array list while you're looping through it. So here's what that looks like. If we call a for each loop and we say something like ArrayList.remove string, just like that. So again, string represents the value in our array list that we're actually dealing with when we loop through in our for each loop. So if we say ArrayList.remove string, that'll just take it out of the array list and everything should be fine. This should theoretically clear our array list, but if we run it, we get an error that says concurrent modification exception. That basically just means you're modifying the array list while you're looping through it with a for each loop. So you need to be more careful when you're dealing with for each loops. So if we replace this instead with a for loop, just a regular one, if we say ArrayList.size, you still need to be careful, because if we say ArrayList.remove I, well, every single time we remove, let's say we remove 0, then the next index becomes 0. So we would still want to remove 0. So you could either do one of two things. We can say ArrayList.remove 0, like that. Oops, hold on. Almost there. There we go. We can say ArrayList.remove 0 and just do it however many times you have an item in the array list. Or you can do something a little bit more complicated, but it still works nonetheless. So instead of starting at 0, we would actually start at the highest index, which is ArrayList.size minus 1, and we would go down to 0, where I is greater than or equal to 0. And then to go down, we would say I minus minus instead. Then we can say ArrayList.remove I, because that would start at the highest index, it would remove it, and because there's nothing below it, nothing would get shifted. So then this index wouldn't change, and this index wouldn't change, and then 2 wouldn't get changed, and then 1 wouldn't get changed, and 0 wouldn't get changed. So those are the two different ways that you could remove everything, or just remove values in general. Or you could just use ArrayList.clear, and that'll do that process for you. That clears out your array list. So those are just some tips and tricks for dealing with array lists, especially if you're removing items or using your for each loops. So just some things to keep an eye out for. If you ever see this concurrent modification exception, that means you can't remove items while you're using a for each loop. And if you're having problems where you're removing the items but items are getting skipped over, that's probably because you're starting at 0 and going up and you're removing I or something like that, and so the values of your index are actually changing as you're removing the items. So again, something to keep an eye out for, but that's the basics of an array list. And one more thing before I end this video. You might be thinking, if you want to create an array list of integers or ints, you would just say int in the brackets like that, and we would call it num list or something like that. It doesn't matter. It's just what I'm choosing to call it. And here you actually don't even need to specify the type inside the diamond brackets again, if you don't want to. But here we're getting an error that says insert dimensions to complete reference type. So it doesn't like the fact that we're saying int. Instead, we need to reference the class of integer. So we need to spell out integer with a capital I, because the int is actually it's a data type that's created from the integer class. So it still works the exact same way. We can still say like numList.add 10. We don't need to do anything special. We just need to be mindful when we create the array list. So that's it for this video about array lists. I should be talking about classes and objects pretty soon, but I haven't quite decided on what I'll do for my next video. Anyway, I will see you in the next video.